After years of anticipation, astronomers have finally captured the first clear image of Betelgeuse's long-suspected companion star. And this discovery could solve many mysteries surrounding one of the most famous stars in the night sky. But what scientists found about this companion is both fascinating and alarming. They now believe Betelgeuse may eventually consume it. Before we dive into this new discovery, let's explore why it's such a big deal. Have you ever wondered what would happen if a star close to Earth suddenly exploded? It's a thrilling and slightly terrifying thought. In fact, around 2.6 million years ago, a star did go supernova roughly 150 light-years away. That explosion may have triggered a mass extinction on Earth, especially among large marine animals. Our star, the Sun, provides the steady warmth and light that makes life on Earth possible. It's a middle-aged star, fusing hydrogen into helium in a stable, predictable cycle. Fortunately, it will continue this calm existence for another 5 billion years. But this stellar tranquility is not universal. Across the cosmos, not all stars are so serene. Some are giants, hotter, more massive, and far more volatile. These titans burn through their fuel at a ferocious rate. When their core can no longer support their immense weight, they collapse and then rebound in a spectacular supernova explosion, one of the most energetic events in the universe. A few of these potential supernovae, like the brilliant blue stars Spica and Rigel, or the red supergiant Antares, are relatively nearby in cosmic terms. But at hundreds of light-years away, their eventual explosions pose no direct threat. Earth is well outside the kill zone, safe from any harmful radiation. Still, the spectacle would be breathtaking. Their explosions would be so bright they could outshine the full moon for days or even weeks, casting shadows at night and remaining visible even in broad daylight. Among these colossal stars, one stands out as a prime candidate for the next galactic supernova: Betelgeuse, a pulsating red supergiant about 642 light-years away in the constellation Orion. That vast distance means the light we see from it tonight is ancient history. It actually left the star around the year 1382 during the late Middle Ages here on Earth. This creates a fascinating possibility. It's conceivable, though statistically unlikely, that Betelgeuse has already exploded. We just wouldn't know it yet because the light from that cataclysmic event is still racing across space, on its centuries-long journey to reach our eyes. For years, scientists have kept a close watch on Betelgeuse, one of the brightest stars in our night sky. As a red supergiant nearing the end of its life, its strange and unpredictable behavior has fueled intense speculation that its final spectacular moments may be near. This isn't just an academic curiosity. A supernova this close would be the astronomical event of a lifetime. Recently, a new, incredibly detailed image taken by an advanced observatory has peeled back another layer of the mystery, revealing even more surprising details about this cosmic giant. The data collected has allowed astronomers to construct the most complete picture of its activity to date. By meticulously analyzing years of observations, astronomers found that Betelgeuse's brightness doesn't just change, it fluctuates in 3 distinct ways. Each of these variations is caused by a completely different physical phenomenon, painting a complex portrait of a star in turmoil. The most dramatic and widely publicized event was the Great Dimming of 2019. Over several months, the star's light suddenly dropped by an astonishing 35%, a colossal change for a star of this magnitude, visible even to the naked eye. At first, scientists were baffled, with some wondering if this was the prelude to a supernova. But closer study revealed that Betelgeuse had violently ejected a massive cloud of its own material, a surface mass ejection far larger than anything our Sun produces. As this superheated gas travelled away from the star, it cooled and condensed into a vast opaque cloud of dust. When this dust drifted into our line of sight, it acted like a cosmic smoke screen, blocking the star's light and making it appear significantly dimmer from Earth. The second kind of dimming is far more predictable. It occurs in a regular rhythmic cycle, repeating roughly every 400 days. This is caused by the star's natural internal pulsations, a slow, steady expansion and contraction of its outer layers, almost like a colossal beating heart. These pulsations are a key diagnostic tool, allowing astronomers to probe the star's turbulent interior and model its structure. They confirm that Betelgeuse is in an advanced stage of stellar evolution, burning through its fuel and approaching its final phase, though they don't signal an immediate explosion. But it's the third type of dimming that has proven to be the most profound mystery. This variation repeats on a much longer timescale, roughly every 6 years, and it doesn't match any known internal activity or dust formation models. It's a ghost in the machine, a pattern that defies our current understanding of how single stars like Betelgeuse should behave. For decades, this unexplained 6-year pattern puzzled astronomers. It was a persistent anomaly in the data that no one could account for, until a team of researchers proposed an elegant and intriguing idea. What if Betelgeuse isn't alone? What if this entire time it has had a hidden partner? One compelling theory was that a smaller companion star orbited Betelgeuse. As this unseen partner circled the supergiant, its gravitational pull could be distorting Betelgeuse's shape, creating massive tidal bulges on its surface. As Betelgeuse rotates, these bulges would face us, then turn away, causing the periodic changes in light we observe from Earth. This elegant solution could neatly explain the star's rhythmic dimming. Astrophysicists ran complex computer simulations to model this cosmic dance. The results were specific. To produce the observed 6-year cycle, the companion would need to be a substantial object, perhaps 1 to 2 times the mass of our own Sun. Furthermore, it would have to orbit incredibly close to the red supergiant, deep within its gravitational well, to exert enough influence. But there was a huge problem. Detecting such a faint object right next to a star as overwhelmingly bright as Betelgeuse seemed nearly impossible. It would be like trying to spot a firefly next to a searchlight from miles away. Any signal from the companion would be completely lost in the supergiant's blinding glare. Then came a breakthrough. Using a high-resolution instrument called Alopeke, attached to the Gemini North Telescope in Hawaii, astronomers employed a clever technique called speckle interferometry. By taking thousands of rapid short-exposure images, they could effectively cancel out the blurring effects of Earth's atmosphere and the overwhelming glare of Betelgeuse. And there, emerging from the noise, was a faint object beside the star, its long-sought companion, now named Saura. The discovery was a perfect match for the simulations. Saura is roughly 1.6 times the mass of the Sun, orbiting Betelgeuse at about 4 astronomical units, a distance even closer than Jupiter is to our Sun. Its orbital period of 5.94 years aligns perfectly with Betelgeuse's 6-year brightness cycle, confirming it as the cause. The mystery of the rhythmic dimming was finally solved. But in solving one puzzle, astronomers uncovered something even stranger. Saura isn't a fully formed star. It's a pre-main sequence F-type star, meaning it's still in its infancy and hasn't yet ignited nuclear fusion in its core. It's a protostar, shining only from the heat of its own gravitational contraction. In other words, it hasn't even switched on. What's remarkable is that both Betelgeuse and Saura were born together from the same cloud of gas and dust. Yet, while Betelgeuse is nearing the end of its short, brilliant life, Saura's has barely begun. It's a stunning contrast that shows how differently stars evolve depending on their mass. Massive stars like Betelgeuse live fast and die young, while smaller ones develop slowly and can live for billions of years. Scientists now believe Saura may never fully ignite, its fate likely sealed by Betelgeuse's powerful gravity. In fact, calculations suggest that before Betelgeuse goes supernova, likely within the next 100,000 years, it could draw Saura inward and consume it, an act of stellar cannibalism that might occur within 10,000 years. Astronomers expect their next clear view of Saura in November 2027, when it reaches maximum separation from Betelgeuse. Each new observation brings us closer to understanding this extraordinary system, and how massive stars evolve, interact, and eventually meet their explosive ends. Whether Betelgeuse explodes tomorrow or thousands of years from now, one thing is certain. Its story is far from over, and now, with a companion star in the mix, it's more captivating than ever. Thank you for watching. If you found this discovery as fascinating as we did, share your thoughts in the comments below. Your support helps us keep exploring the universe together.